Hello friend, welcome to BRiCS embedded system tutorial. Till now we have learned how to install softwares, how to prepare hardware, how to configure Eclipse and how to create first project inside Eclipse, or maybe if you are interested you can use work with a command prompt or programmer's notepad. Now in this tutorial we are going to learn how to write a program for AVR microcontroller. So to start writing program for AVR microcontroller, we actually need to know the details of microcontroller. So here is my microcontroller at Mega 16. In this microcontroller there are 40 pins. Pin number 1 starts from the top left corner and pin number 40 is at the top right corner. Out of these pin number 40 to pin number 30 is actually called port A. Top pin number 40 is 0th bit and pin number 33 is 7th bit. These 8 pins or these 8 bits are actually representing 1 byte. So we can assume that the MSB of that byte is pin number 40 and MSB of that byte is pin number 33 and LSB is pin number 40. Similarly, we have pin number 1 to 8 called port B, pin number 22nd to 29th is called port C, and pin number 14th to pin number 21st is called port D. All these four ports having 8 pins represents 1 byte, and in slide you can see that A, B, C, D all are having MSB as well as LSB. Now other than these 32 pins, one pin is a reset pin. There are two VCC. One is actually AVCC, pin number 30 is AVCC, which is used for ADC. There are two ground pins. One pin is called A reference, which is used for again ADC, and there are two pins used for crystal oscillator. So this is the complete pin diagram of at Mega 16. Port A, port B, port C and port D. Other than that we have some A reference pin, AVCC pin, ground, VCC and crystal pins. To handle a single port, let's assume port B, there are three registers, three 8-bit registers inside our microcontroller. These registers have some special name: port B, DDR-B and pin B. Whenever we want, we can write some number on these registers, like I have representation of these numbers in decimal as well as binary. So here we have written port B equal to 12, and in case of binary you can see it's 00001100. Similarly, I have written port B equal to 33, so in binary it's written 00100001. Similarly, we can write some number on DDR-B also, that is 69 01000101. Now, when the largest number which we can write on 8-bit register is 255. If we will write 255 on any register, all the bits of that register will become 1. Now we have left with the last register called pin B. Pin B is not a writable register. We don't have any direct facility to write something on pin B. But the metallic pins which are visible outside your microcontroller, like pin number B0 or pin number 1 of microcontroller, is actually this bit of pin B. Similarly, pin number 2 of microcontroller is this bit, pin number 3 is this bit, and so on. So whenever we want to connect some external device, like simply we can connect one LED to one pin like this. I have connected one LED to this pin. So this LED will actually get connected to the register called pin B, and we know that we can't write something on pin B directly using this statement, pin B equal to something. So to write something on this bit, actually we need to get help from the top two bits, DDR-B bit and port B bit. So let's see how these two bits can help us in changing this bit. So the role of DDRB is whenever you will write 1 on this bit, whenever you will write 1 on this bit, the corresponding bit of port B and pin B will get connected. Internally there is a facility that whenever you will write 1 on this, these two bits will get connected. Similarly, if you will write 1 here, this bit and this bit will get connected. Similarly, now whenever you will write 1 on port B, as we know that we have full facility to write something on port B. So whenever you will write on 1 on this bit will become 1 automatically, because these two bits are connected now. Here also this bit and this bit are connected, but here it's written 0, so this will remain 0. Now these two bits are not connected, so if you will write 1 here, this will not become 1. Now if we will write 1 on this bit also, this will become 1 and your LED will glow. Similarly, if we want, we can connect 8 different LED on 1 on each pin. We can write DDRB equal to 255, and whatever number I will write on port B, like here we have written port B equal to 128, same number will get reflected on pin B register. So if you write port B equal to 128, this LED will glow. If you write port B equal to 172, this two LED will glow, and so on. If you will write different number, accordingly LEDs will blink. If you will write port B equal to 255, all the LED will glow. So now let's try to write all these codes on some editor and compile and transfer it, and let's see if these things are working. So here is the code which I had created in last tutorials. So what I will do, I will write DDR, let's say we can select D port. So DDRD equal to 255, and here I will write PORTD equals to 1. Now just compile this code and transfer it. It's transferring. So code has been transferred. Let me show you how this thing is working. This series of LED is connected to port D. This is actually D0 and this is D8. So only one LED is glowing because I have written port D equal to 1. Now if I will write port D equal to 128, again if I will transfer the code, now you can see this LED is glowing and all others are not glowing. Now if we can write some code like after glowing this LED, after switching on this LED, we can put some delay. 1000 millisecond delay is there, and after some time I am switching it to port D equal to 1. Again transfer the code. So here you can see, first this LED is glowing, then this LED is glowing, then again this LED, again this LED, again this LED. Okay, so now you can see LEDs are glowing like first LED, second LED, third LED, fourth LED, fifth LED, sixth LED, seventh LED, eighth LED. Again it will go to 1, 2, 3, 4, 5, 6, 7, 8. So in this way, whatever pattern you want, you can generate using by writing just some code. So that's all for this tutorial. In next tutorial we will learn more about how to write code for LED blinking. Thank you for watching this tutorial. Please keep watching our tutorial to learn more about embedded system. Thank you.